So students, please be note down on problem regarding that feature information, and also can discuss the capacity of the channel also. No? The capacity of channel depends on the prospective density of the signal transfer. That is depending upon the mutual information concept. So if the signals are number of signals are transferred through a channel, if the one of the signal have the maximum prospective density, so that is the entire channel capacity. That is the entire channel capacity. So I hope you are also done the problem on the channel capacity also. So please note down in this problem. So that the channel capacity of a binary symmetric channel when P of x1 is equal to alpha, P of x2 is equal to 1 minus alpha, and P is equal to 0.5, and at P is equal to 0.1. So that is the problem. Already in this channel capacity concept, the mutual information plays an important role. Mutual information plays an important role. So in the binary symmetric channel, there is two inputs and two outputs are there. X1 and X2 are the inputs and Y1 and Y2 are the outputs. So there is a probability of P and 1 minus P. So the mutual information of binary symmetric channel is 1 minus P log P plus 1 minus P log 1 minus P. So that is already did a problem regarding to that. I of x comma y is the mutual information of the binary symmetric channel is equal to h of I plus P log P plus 1 minus P log 1 minus P. So here it is, the channel capacity of binary symmetric channel is the maximum of P of x, where the P of x is maximum, that is the channel capacity. I of x comma y bits per symbol. Now, so that is if the alpha is 0.5 at P is equal to 0.1, then I of x comma y is equal to 1 minus 0.45. 1 minus 0.45. That is equal to 0.534. 0.534. So already, the channel capacity of the binary symmetric channel is depends on the mutual information. The mutual information of the binary symmetric channel is h of I plus P log P plus 1 minus P log 1 minus P. For the binary symmetric channel, there are two inputs are there, alpha and 1 minus alpha. If suppose one of the input is 0, another input is 1. Likewise, you can binary symmetric channel is have the binary data as input. So now, if suppose C of S is equal to at probability of 0.5 and alpha is equal to 0.5. Alpha is equal to 0.5 means 1 minus alpha also 0.5. That is, there are equal probability, equal symbols are as input. 0.5 is the one of the input and 0.5 is another input. So in that case, that is the probabilities, no? In that case, channel capacity is equal to 0.534. So if alpha is equal to 0.5, P is equal to 0.5. At P is equal to 0.1, channel capacity is equal to 0.534. At P is equal to 0.5, the channel capacity is equal to 1 minus 1, 0. 1 minus 1, 0. can draw this waveforms like this. P is equal to 0.5 the maximum and capacity is 1. So the graph is like this. So this is the channel capacity. For the channel capacity, to calculate, one more alternate method is there. That alternate method is, if suppose x1, x2 are the inputs and y1, y2 are the outputs, p11, p12, p21, p22 are the paths between x1 and y1, x1 and y2, x2 and y1, x2 and y2. So that is p11, p12, p21, p22. So now you can arrange the channel matrix like this. You can arrange the channel matrix like this. That is P11, P12, P21, P22. P11, P12, P21, P22. Q1, Q2 are the constants are here. We can arrange the column. So that is equal to P11 log P11 plus P12 log P12 and P21 log P21 plus P22 log P22. So this is the alternate method to calculate the channel capacity. So in general method, channel capacity depends on the mutual information. So where the input power difference is maximum, that is the channel capacity. Now it is the alternate method. It is the alternate method to know the channel capacity. So students, please be note this formula. P11, P12, P21, P22, arrange the matrix, multiplied with Q1, Q2, multiplied with Q1, Q2, that is equal to P11 log P11 plus P12 log P12, P21 log P21 plus P22 log P22. This is the formula to know the channel capacity in the alternative steps, where Q1 and Q2 are the variables. So solve the Q1 and Q2 values and find the channel capacity. Then the channel capacity is equal to C of S is equal to log 2 to the power of Q1 plus 2 to the power of Q2 base 2. So C of S is equal to channel capacity is equal to log 2 to the power of Q1 plus 2 to the power of Q2 base 2 bits per second. Okay, this is the channel capacity. For the above problem, please find the channel capacity. Find the channel capacity of given channel when P of x1 is equal to 0.6, P of x2 is equal to 0.4, and the channel is given like this. It is a binary arithmetic channel. That is, two inputs and two outputs are there. X1 and x2 are the inputs, y1 and y2 are the outputs. So the probabilities are 0.8, 0.2, 0.3, 0.7. 0.8, 0.2, 0.3, 0.7. It's given. So simply you have to arrange the channel matrix P11, P12, P21, P22. That is equal to P11 means 0.8, P12 means 0.2, P21 is equal to 0.3, P22 is equal to 0.7. So you can arrange the channel matrix like this. That is multiplied with the Q1 and Q2. So initially you have to do the problem on the in general process. The general process is arrange the channel matrix. And P of x comma y is joint probability. Joint probability is considered as P of x1 y1, P of x1 y2, P of x2 y1, P of x2 y2. That is equal to 0.6, 0, 0, 0.4. So multiplied with 0.8, 0.2, 0.3, 0.7. Then what is 0.6 and 0.3? 0.6 and 0.4. Simply these are the inputs. So can what is P of x comma y? P of x comma y is the x comma y is the joint probability that is equal to P of x in the diagonal form multiplied with channel matrix. P of x in the diagonal form. This is the diagonal form. 0.60, 0.4 multiplied with channel matrix. Channel matrix is 0.8, 0.2, 0.3, 0.7. So then can multiply with 0.48, 0.12, 0.12, 0.28. Now h of y is equal to sigma p of I log 1 by p of I, no? So p of I 1 is equal to 0.6, p of I is equal to 0.4. Then can calculate p of y is equal to p of I is equal to sorry, h of y is equal to h of y is the entropy of the output. P of I1 is equal to 0.6, P of I2 is equal to 0.4, no? 0.6 log 1 by 0.6 plus 0.4 log 1 by 0.4, that is equal to 0.97 bits. 97 bits. So you know the h of y by x. H of y by x is joint conditional entropy or transition entropy. That is equal to sigma I, sigma j, P of x comma y log 1 by P of yj by xi. So if you substitute P of x1 y1 log 1 by P of y1 by x1 plus P of x1 y2 log 1 by P of y2 by x1 plus P of x2 y1 log 1 by P of y1 by x2 plus P of x2 y2 log 1 by P of y2 by x2. So that is equal to 0.64 log 1 by 0.8 plus 0.12 log 1 by 0.2 plus 0.12 log 1 by 0.3 plus 0.28 log 1 by 0.7, that is equal to 0.78 bits. Now you know that channel capacity I of x comma y is equal to h of y minus h of y by x, because I of x comma y is mutual information, that is equal to h of y minus h of y by x. H of y is equal to, calculated, this is 0.97. Now the 0.97 minus 0.78, that is 0.12 bits per second. 0.19 bits per second. CFS 0.19 bits per second. This is the generalized process. So the generalized process, what to do? Can calculate the I of x comma y, that is mutual information. Then where the mutual information input bits are maximum, that is the channel capacity. So in this problem, channel capacity is 0.19 bits per second. So now the same problem do in the alternate method, that is arrange the matrix as 0.8, 0.2, 0.3, 0.7 multiplied with the Q1 and Q2 values, that is equal to 0.8 log 0.8 plus 0.2 log 0.2 and 0.3 log 0.3 plus 0.7 log 0.7. So simply can arrange when the channel matrix probabilities are known, that is P and 1 minus P is known. Then you can arrange the channel matrix and multiply with Q1 and Q2 values, Q1 and Q2, and that is equal to P11 log P11 plus P12 log P12, like P21 log P21 plus P22 log P22. So that is the formula applied here. When you can, for this problem, 0.8, 0.2, 0.3, 0.7, Q1 and Q2 multiplied with 0.8 into Q1 plus 0.2 into Q2, that is equal to 0.8 log 0.8 plus 0.2 log 0.2. So once you can simplify this value, that is called minus 0.72. Minus 0.72. That is called 0.8 Q1 plus 0.2 Q2 is equal to minus 0.72. Minus 0.72. Minus 0.72 is calculated from 0.8 log 0.8 plus 0.2 log 0.2. So like 0.3 into Q1 plus 0.7 into Q2 is equal to 0.3 log 0.3 plus 0.7 log 0.7. Where is the logarithmic base 2 only? You can use the logarithmic base 2. Students, please remember that here you can use the logarithmic base 2. Now, there are two quadratic equations are here. One is 0.8 Q1 plus 0.2 Q2 is equal to minus 0.72. Another one is 0.3 Q1 plus 0.7 Q2 is equal to 0.88. Therefore, you can solve these two equations. To solve these two equations, Q1 and Q2 are known. Q1 is equal to minus 0.656, Qt is equal to 0.88. Qt is equal to 0.88. Once Q and Qt values are known, then find out the channel capacity. Channel capacity C is equal to log 2 to the power of Q1 plus 2 to the power of Q2 base 2. Okay. So Q1 Q2 values are Q1 is equal to minus 0.656, Q2 is equal to 0.88. So simply substitute in the formula 2 to the power of minus 0.656 plus 2 to the power of 0.88. Now the value is 0.192 bits per second. 0.192 bits per second. So compare with the previous method and this method, channel capacity is equal to 0.192 bits per second. So here also the same, 0.192 is the bits per second is the channel capacity. So students, please be follow the alternate method when the examiner gives the allot the minimum marks for that. That means if suppose if the marks are assigned as 2 or 3, you can follow the alternate method. Simply, if they ask channel capacity, otherwise you can follow the in general method. That is general method. Calculate the I of x comma y. That is mutual information. From that, you can calculate the channel capacity. Okay, this is the method. So now, if suppose here Q1, Q2 are multiplied because of 2 inputs and 2 outputs, and one binary symmetric channel is there. If suppose add another binary symmetric channel as cascaded. If suppose in this problem, please note down this problem. Find the channel capacity of given channel. Find the channel capacity of given channel. The channel is cascaded one. Cascaded one means there are 3 channels are cascaded here. This given channel. X1, X2 are the inputs, and these are the outputs. Outputs are given to second channel, and second channel output is given to third channel. Third channel outputs are Y1 and Y2. Now the third channel outputs are Y1 and Y2. The first channel inputs are X1 and X2. Now the third channel outputs are Y1 and Y2. Now the probabilities are given here: 0.8 to 0.37, same as 0.8 to 0.37, 0.7, 0.8, 0.2, 0.3, 0.7. That means the same binary symmetric channel added as cascaded. Now the 3 channels are cascaded in the arrangement. Now can calculate the overall channel, that is cascading of all these 3. Now we can multiply the channel matrix of 3. What is the channel matrix of the first one? 0.8, 0.2, 0.3, 0.7. Like the second one also 0.8, 0.2, 0.3, 0.7. The third one also 0.8, 0.2, 0.3, 0.7. So now the 3 channels are cascaded, the same binary symmetric channels. Now you can multiply these 3 as matrix multiplication. Then the resultant channel is 0.608, 0.608, 0.392, 0.392, 0.608. So this is the overall transistor matrix. Now that overall transistor matrix is 0.698, 0.392, 0.392, 0.698. So everywhere you can see that the row sum should be the unity. Then only the channel is existing channel. If not, the channel is not existing. The row sum should be unity. Now the overall channel is, this is the channel. Multiplication of the 3 individual channels. Multiplication of the 3 individual channels. Now it is overall channel is known. Now that multiplied with Q1 and Q2 values, again use the same formula, that is 0.68, that is P11, P12, P21, P22. That P11 log P11 plus P21 log P21, P12 log P12 plus P22 log P2. So that is P11 is equal to 0.608, P12 is equal to 0.392, P21 is equal to 0.392, P22 is equal to 0.608. So now can multiply the Q1 and Q2 values. So now the 0.608 log 0.608 plus 0.392 log 392, 0.392 log 0.392 plus 0.608 log 608. Students, please we calculate these resultant first. So then you can follow this. That is 0.608 Q1 plus 0.392 Q2 is equal to this value is now. Like 0.392 Q1 plus 0.608 Q2 is equal to this value. Now, after solving this Q1 and Q2 values, Q1 is equal to minus 0.966, Q2 also minus 0.966, the same values. Then the channel capacity, C is equal to 2 to the power of Q1 plus 2 to the power of Q2, 2 to the power of Q1 plus 2 to the power of Q2, 2 to the power of Q1 plus 2 to the power of Q2. So that is equal to 0.034 bits per second. 0.034 bits per second is the channel capacity. So that is the cascaded one. This is the cascaded one. The cascaded one, input is 2 and output also 2. Simply the cascading of the number of channels. If this previous one, there are 3 channels are cascaded, then inputs and outputs are the same. Inputs and outputs are the same. So because of 2 inputs and 2 outputs, Q1 and Q2 are the multiplication constants here. Q1 and Q2 are the Q1 and Q2 number. Q1, Q2 number, it depends on 2 outputs only. If suppose the channel is cascaded or not, if there are 2 outputs, then multiply the channel matrix with Q1 and Q2. That is equal to P11 log P11 plus P22 log P22, so on that. So if suppose outputs are 3, how it is? Then find the, please note of this problem. Find the channel capacity of the given channel. Find the channel capacity given channel. X1, X2, X3 are the inputs. X1, X2 or X3 are the inputs. Y1, Y2, Y3 are the outputs. So what is this channel? This channel is two binary symmetric channels are arranged in parallel, not the series. The added in the series, that is the cascaded one. Now the 2 channels are arranged in the parallel. 2 are in the parallel. That is parallel connection is. Parallel connection is X1, X2 are the 2 inputs and Y1, Y2 are the 2 outputs of the binary symmetric channel. Like X2, X3 are the 2 inputs and Y2, Y3 are the 2 outputs of the binary channel. These 2 binary channels are arranged in the parallel one. Then calculate the channel matrix. How you calculate channel matrix here? How you calculate channel matrix here? So the channel matrix is, this is P11. P11 means Y1, X1. Y1 output, X1 input. P11. This is P12. P12. So that is 1 is an input, 2 is an output. 2 is an output. P12. This is P13. 1 is an input, 3 is an output. So like this is P13. 2 1. 2 is an input, 1 is an output. P 2 2. 2 is an input, 2 is an output. P 2 3. 3 is an output, 2 is an input, 3 is an output. This is P 3 1. 3 is an input, 1 is an output. This is P 3 2. 3 is an input, 2 is an output. This is P 3 3. 3 is an input, 3 is an output. Likewise, P1 1 is equal to 0.8. P1 2 is equal to 0.2. P1 3 is equal to 0. Why? Because it is 0. Why? Because it is 0. There is no connection between 1 and 3. That means x1 and x3, x1 and y3, there is no connection. No? X1 and y3, there is no connection. That's why it is 0. So this is P21. P21 is 0.1. P22 is 0.8. P22 is 0.8. So students, here the diagram printing mistake is there. You may not assign 0.8. Please be note that this is 0.8. This is the 0.8. P22 is 0.8. P23 is 0.1. So P31. Is there any third input and one output? That means third input means x3. One input output means y1. X3 y1. Is there any connection? So there is no connection. That's why it is 0. That's why it is 0. And it is P32. P32 is called 0.2. P33 is called 0.8. That is 0.8, 0.2, 0, 0.1, 0.8, 0.1, 0, 0.2, 0.8. Now Q1, Q2, Q3 are the multiplication factors. So why you can multiply these three instead of 2? The earlier one 2, Q1, Q2. No. Now it is multiplied with the 3, Q1, Q2, and Q3. So because of there are 3 outputs. There are 3 outputs. That's why Q1 and Q2 and Q3 will come into the picture. So that's why now this is channel matrix multiplied Q1, Q2, Q3. So this multiplication is equal to 0.8 log 0.8 plus 0.2 log 0.2 plus 0.3 log point. That means P11 log P11 plus P12 log P12 plus P13 log P13. So that is P11 is equal to 0.8 log 0.8 plus P12 is equal to 0.2 log 0.2 plus P13 is 0. That's why it is 0. Like P21 log P21 plus P22 log P22 plus P23 log P23. That is 0.1 log 0.1 plus 0.8 log 0.8 plus 0.1 log 0.1. That is that third one is P31 log P31 plus P32 log P32 plus P33 log P33. So that is P31 is 0. That's why 0 plus P32 is 0.2 log 0.2. P33 is 0.8 log 0.8. So simply can multiply Q1, Q2, Q3 values with the channel matrix that is equal to this value. Now channel capacity is C is equal to 2 to the power of log 2 to the power of Q1 plus 2 to the power of Q2 plus 2 to the power of Q3 also, because of 3 variables here. Log 2 to the power of Q1 plus 2 to the power of Q2 plus 2 to the power of Q3. So that is channel capacity. That is the channel capacity. So now to solve this problem at your own, calculate the channel capacity. So simply you expect two types of problems in this. One is channel cascaded one, another one is parallel one. Okay, students, please be go through the textbook and solve the problems. So I also shared my notes with you. Okay, so in the next class, go for source coding and channel coding. Okay, so now the next class to go for another concept. So up to this, can complete the fourth unit. Fourth unit is completed. Fourth unit is up to mutual information. So along with channel capacity also. Okay. The next class go for fifth unit. Fifth unit completed some of the portions, that is source coding techniques. Shannon Fano coding and Hoffman coding is completed now. Those are in the command of the chapter of 5. Chapter of 5. Okay. So now the next class go for some more topics in the fifth unit. Okay. So please be practice the problems and the concept also. So thank you for attending. Thank you one and all.